Okay, in this particular problem, we're going to first read the problem. In the word problem, it's going to discuss both the cost of tickets, the total cost that was received for tickets, and then how many actually attended between adults and children. So I'm going to come up with a word problem. The first is just going to talk about attendance. Who attends? So I know there's children and I know there's adults, and together it says there are 12,600 that attended on one particular day. Now the cost, it costs $150 for a child and it costs $450 for an adult. And together on that same particular day, they were able to take in $3,000 in tickets. So when I look here, this is a matrix, and if you don't see a number in front, it's a 1. So I can see there's 2 different rows here. There's 2 rows, and there's 3 columns. So the first thing I'm going to do is I'm going to come over here, and if you're wondering how to get here, you're going to type in Desmos RREF matrix, press enter, and click on it. And I'm going to start a new matrix, typing in 2 rows and 3 columns, and now typing those numbers. So in front of the C was a 1, in front of the A was a 1, and the total attendance was 1,260 people. It was $150 for a child, it was $450 for adult, and in all, they were able to take in $3,000 in tickets. I press enter, and now I do the RREF of matrix, in this case, matrix A. So how do I know which one represents how many children attended and which one represents how many adults attended? Well, if you come back here and look, we organized it, we organized it so C came first and A came second. C first, A second. So when I look at the answers, the C has to come first again. So I'm going to write this down. I'm going to put C equals 890, A equals 370. Then I come back to the question and I read carefully. How many adults? 370. Okay, so in this particular problem, we are going to solve and find a unique value or values of X that make the statement true. Now, I'm going to teach you right now how you can cheat. In this particular problem, I'm going to demonstrate once again how do we get A and B. So how do we get A and B? We hit math, we go 1 cursor over to NUM for number and press enter. That stands for ABS is for absolute value. I'm going to type in 3, hug option A, which is 3, subtract 2, and we can see we get an answer of 7. I'll do the same thing for B. Math, scroll over to NUM, press enter. Again, I do 3, I have to hug this choice right here of -5/3. -5/3, it has to be in parentheses. Subtract 2, and I can see I get 7. These other 2 I end up with 17 and 25. They do not equal 7, so I have 2 answers. So what are we doing in problem number 3? They already set this up and they organize it. We have R's, we have S's, we have T's, and we have answers. Now what happens when you don't see a number in front of a variable? It is a 1, so put a 1 in front of the S. Rows are equations. How many separate equations do I have? 3, so I rewrite 3 rows. Now watch, 1, 2, 3, 4. There are 4 columns. There's always one more column than row. So I'm going to plug this in just like I see it. When you're opening this up for the first time, remember you're coming up here and you're typing in Desmos RREF matrix. And I have to create a new matrix. Now I need to make the dimensions or the size match what I have. As a reminder, I have 3 rows, like 3 equations, and there's always one more column than there is row. So it's a 3 by 4. So I need to change this. 3 rows, 4 columns, and I just plug in the numbers I see. So -6, 5, 2, and -11, and you guys can continue to plug them in. Before you actually settle with an answer, make sure you have correctly plugged in the matrix. Sometimes when I'm hurrying, I find myself making small mistakes here, so I'm just going to go back and check. Okay, everything looks good. So once you plug this in, you're going to press enter. Okay, we just put in the matrix. Then I'm going to do RREF. This is matrix A. And now I have to make sense of this. I'm like, well, what are these things? Okay, remember, let's look here. R went first, S went second, T went third. So everybody put R, S, T. It's going to give us the answers in that particular order. So my R is first, so R is 4, S is 3, and T is -1. Okay, let's come back here and let's think about this. What does it say? It says, what is the value of S? The value of S is 3. All right, so which of the following formulas are going to model this sequence? So we know we're going to have one answer, okay? We know we're going to have one answer. When you see a sub 1, it means the first number. So the first number is -3. Everybody write that down. The common difference, this should have been an N, sorry. The common difference is how do you get from one number to the next? Some people are just going to use mental math. So some people are going to go, how do I get from 7 to 12? I add 5. Do you guys agree with that? Okay, so I can go common difference, I'm adding 5. See how I did a plus 5? Other people like to do it this way. And let's do this with me, please. Put the second number in parentheses. I don't know why it's there. And then subtract the first number in parentheses. Put the second number in parentheses, subtract the first number in parentheses. Okay, press enter. Do you see how we still get a positive 5? You can do either one. You can do either one. Second number minus the first. It's not first minus second. It's second number minus first. Or you could rely on mental math. How do I go from -3 to 5? I add 2. How do I go from 2 to 7? Add 2. How do I go from 7 to 12? I said add 2. Add 5, add 5. Okay, so I know I'm adding 5. This is what I'm going to use to actually come up with a formula that models this. So here we go. A sub n equals, the first number is -3 plus the common difference is 5 and then n minus 1. Now I'm going to distribute that positive 5. When I distribute, I multiply. So 5 times n is positive 5n. 5 times -1 is -5. And don't forget about the -3 that was out front. There are 3 terms here, and only 2 of them can be combined. -3 and -5 combined to give you a -8. Let's look up above. Do we see this as an option? Sure do. Is there a way to test this to make sure that what you came up with is correct? Is there a way to get the answer if you forget how to do this, even knowing that this will be on the board? There is. So I'm going to teach you a way to cheat because you have multiple choice. Everybody pick up that calculator, please. Here we go. You ready? Above this -3, write 1. Above the 2, write 2. Above the 3, above the 7, write 3. Above the 12, write 4. What am I doing right now? I'm teaching you an alternative way to get the correct answer, an alternative way. So here we go. I'm going to plug this portion in, and wherever I see an n, I'm going to plug in a 1. So I'm inputting in 1 because it's the first number, and I want to see, does this answer equal -3? So do this with me. I have -3. Okay, now I'm going to hug the 1 because it's the first number in the sequence, and add 2. So I literally just plug this in, but I substituted in 1, the input, for n. Press enter. Do we come up with an answer of -1? Sorry, we got an answer of -1. What do we actually want? -3. Cross it out. Can't be that one. Let's try C. So type in 5. We're going to hug -3, and we're going to add 2. I better get an answer of -3 if this is a possibility. Do I get an answer of -3? No. Test for me right now. Test D for me and see what you get for an answer. Test D. I'm plugging in -3. I'm trying the first number, and I'm subtracting 8. I did not get -3. Now, again, this is an alternative to doing all the math since it is multiple choice. Now let's try doing option B. So I have 5. Let's hug the 1 and subtract, and subtract 8. Oh, I got -3. Let's try it one more time. Let's plug in the second number and see if I get 2. 5, hug 2, subtract 8. Oh, I get 2. 5, hug 3, subtract 8. Oh, I get 7. Does everybody understand? Those are alternative ways. Like, Miss, can I just do it this way? I understand that. Absolutely. Or can you say, hey, I know I'm going to have multiple choice options. Can I also plug it in knowing the input and outputs to choose the answer? You can. So number 5, we have 4 different pictures, and we want to know which one aligns to this picture. Did everybody hear me? So first of all, look at this. Put a little arrow above this. I know there's going to be a breaking point. Where x equals 5, there's going to be a breaking point. That means I'm going to do one graph like this to the left, because see the arrow to the left? And I'm going to do this graph to the right. But it's going to break at x equals 5. Like if I could put a wall here at x equals 5, you'd see one graph to the left and one graph to the right. So let's first just check, is the breaking wall there? So here is, because these go by increments of 5. Does everybody see how it breaks here at 5? That could be it. Does everybody see how it breaks here at 5? That could be it. It breaks here at 5. Okay, that could be it. Does it break here at 5 for option D? Cross it out. Cannot be that option. Okay, so it breaks at 5. I'm going to see if I have a highlighter so it just stands out a little more. This is like the breaking point of each of these. And the arrow says which way. So this equation will be, look at this arrow, will be to the left. Is this a positive slope or a negative slope?
Positive.
So positive slopes, by the way, they go up. So as you go to the right, they go up. Okay? So I'm going to look at where this line is that represents x equals 5, and I'm going to look at it to the left. Does this have a positive slope? Yes or no?
Yes.
Okay, that could be it. Does this have a positive slope?
No.
Okay, cross it out. Does this have a positive slope?
Yes.
Okay, so I'm down to a 50-50 chance so far. Is everybody comfortable with that?
Yes.
We got a 50-50 chance, all right. So here's what we're going to do. It gets a lot easier. You ready? Grab that calculator. We're going to plug in 5 here. We're going to plug in 5. So here we go. 3 times 5 plus 2. And this line will hit this imaginary boundary at 17. Is this hitting at 17? Is this the value of 17? Tell me.
No.
Is this about a value of 17?
Yes.
Done. I'm going to review that again because that's a lot of information. So I need your pencils and pens down, and you're just watching. One of you is going to have to explain to your partner as if they went to the bathroom, and you're responsible. And I will tell you who's going to be explaining. Okay, are you ready? Here we go. So we have a left side and we have a right side, and they are split by the number 5. So first of all, I look and I'm like, okay, yep, okay, here we go. I can see they split at 5. Yep, they split at 5. Yep, they split at 5. Nope, at 5 they don't split there. That's why this is going to be excluded. So I have 3 options. This arrow says, all right, from that orange line, when we go to the left, this is the equation, and it has a positive slope. So I cover up the other side. So to the left, see the arrow to the left? To the left, is this positive? From left to right, are we going up? Yep, that could be it. Is this positive? No, it's going down. Is this positive? Yes. So now I have 2 choices. So how do I decide which one it is? I plug in this boundary, that wall, which has the number 5, and I plug it into the equation. So I have 3 times 5 plus 2, and I get an answer of 17. When I go, this number here for this line should end on 17. This should end on 17. This ends at about 4. This ends at 17. That's the correct. When I look at number 6, I'm describing this parent function to something that's been changed. Remember on the inside, do me a favor, put a little frowny face here, put a little smiley face here. It lies to you on the inside. The inside is going to tell you whether you're going to go left or right. The back number is going to say whether you're going up or down. So it's natural to be like, move to the right 2 because you see a plus 2. It lies to you. So you're going to go to the left 2. So find the one that says go left 2. Horizontally shift left 2. Circle that. And I'm going to cross out right 2 because I don't want to confuse myself. The back number tells the truth. So we're going to go down 4. So down 4, circle it. And I'm going to cross out the one that says up 4. And remember the number in front, if it's greater than 1, we say a stretch. So vertically stretched by a factor of 3. If there would have been a negative sign there, remember it would also reflect across the x-axis. Okay, in number 7 here, we have a word problem, and it says for us that Anthony helps his father in a lawn business, and he heard his father tell a client that he charges a flat rate of $40 mowing the lawn, but trimming bushes costs $5 per bush. Construct a linear inequality to explain the maximum number of bushes that can be paid for and to mow the lawn with $200. So you can't go over $200. Everybody write down 200. The client says, okay, I've got $200, but I will not give you anything more. So whatever Anthony's father charges, so whatever's going to get charged for the fee, this amount has to be less than or equal to 200. This amount has to be less than or equal to 200. Okay? By the way, you could also write it like this. We could have that amount, and again, this is the amount Anthony's dad charges. It's less than or equal to 200. Now, what is Anthony charging? So, sure, it's automatically going to be the $40. That's automatic, plus $5 per bush. So I could put a B or an X. So either of these is correct. What matters is the amount that Anthony is charging has this point on the inequality symbol facing it. So let's look at our options. Which one does this look like? What option does this resemble? Option C.